All right, so this is the factor theorem. So the opener is write a quadratic function in intercept form. Given two zeros are 4, 0, negative 6, 0. So this was on your last test, but if the zeros are 4, 0, negative 6, 0, then you should be able to write the factors. So you can write f of x equals, or y equals, and then if 4 is a 0, x minus 4 is a factor, and if negative 6 is a 0, x plus 6 is a factor. And then this, once again, divide. You can do synthetic division with the negative 2 because this is a linear binomial. Okay, so the factor theorem says a polynomial, f of x, whatever name it has a factor of x minus k if and only if f of k equals 0. Meaning when you plug in k using synthetic division or synthetic substitution, you get 0 as a remainder. So it's only a factor if you get 0 as a remainder. So it's kind of like the idea of, like, if I say, is 4 a factor of 12, right? And it's like, yes, because it goes in there 3 times and the remainder is 0. But if I said, is 5 a factor of 12? The answer is no, because it goes in there twice and there's a remainder of 2, right? So 4 is a factor, both 4 and 3 are a factor, but 5 is not a factor of 12. All right, so this says, do you understand what it's saying? Okay, so it says, is x minus 1 a factor of this polynomial? So what we're going to do is we're going to do synthetic division. We're going to divide it with the c value of 1, because remember, it has to make this 0. And we're going to see if it's a factor. If we get a remainder of 0 here, it is a factor, because there is no remainder. All right, coefficients, 1, negative 3, negative 7, and 6. Drop the 1, multiply, that's 1. Add, that's negative 2. Multiply, that's negative 2. Add, that's negative 9. Multiply, that's negative 9. And add, that is negative 3. So is x minus 1 a factor? No, because the remainder is negative 3. All right, let's try the next one here. Is x plus 3 a factor of this polynomial? So we're going to use synthetic division with the negative 3, because this is a c value of negative 3. And then our coefficients, there's a 2 on the cube, there's an 11 on the square, there's an 18 on my linear term, and then there's a 9. Drop the 2, multiply, that's negative 6. Add, that's 5. Multiply, that's negative 15. Add, that's 3. Multiply, that's negative 9. Add, that is 0. So since you got a remainder of 0, yes, this is a factor because the remainder is 0. Okay? All right, so it says factoring a polynomial. So now we're going to factor a polynomial. Given that x equals negative 4 is a 0, factor f of x completely. So I want it factored completely. So it's going to be f of x equals, and then I'm going to have my factors. Since negative 4 is a 0, we know x plus 4 is a factor. That's just like the warm-up. But I need to know how many times x plus 4 goes in there. Since x plus 4 is a factor, that means negative 4 is a 0, so I can use negative 4 with synthetic division. So notice it's the c value is negative 4. This is basically telling me what my c value is. It's saying c is, but it's saying x is negative 4. All right, your coefficients. On the cube, there's a 3. On the square, there's a 13. On this linear term, there's a 2. And the constant's negative 8. Now you have to get 0 here. It says that it is a 0. If you don't, you made a mistake. Drop the 3, multiply, that's negative 12. Add, that's 1. Multiply, that's negative 4. Add, that's negative 2. Multiply, that's 8. Add, that's 0. So now I know my other factor is, remember, this started off as a cube, so this is going to go down to a square, linear term constant. So my other factor, let me pull this up here, is 3x squared plus x minus 2. Now, you're going to have to factor this completely. So since this is a trinomial here that has a quadratic and it has a square in it, I have to see if it's factorable. So first off, I look for a GCF. There isn't one. But since there's 3 terms, I can see if I can use this organizational method to factor it. A is 3, B is 1, C is negative 2. A times C is negative 6, B is 1. So do I know 2 numbers that multiply to give me negative 6 and add to give me 1? 3 times negative 2. Don't forget to divide by the A value of 3. This first fraction simplifies to 1 over 1. Since this is a square, this is an x, and this is an x. So now I can write my other factors. So I'm going to write my final answer. F of x equals, don't forget the x plus 4 that you already wrote down. This is x plus 1. And this is 3x minus 2. And now you're completely factored. All right, so it looks like this next part here, it says, as a team, work on the following problems. So this is meant to be practiced here, or this is meant to be practiced here. So I'm not going to do all of them, but I'll do a couple more examples. Let's see. Given that 5 is a 0, find all the solutions. So yeah, this is the same idea. Okay, so I'll do 1, 2, and 3, and then you can try the pair ones. Write a polynomial function with zeros of negative 2, 2, and 3. So you'd have f of x equals a factor of x plus 2, a factor of x minus 2, and a factor of x minus 3. All right, given that negative 4 is a 0 of f of x equals that function right there, factor f of x completely. So we're going to start by saying f of x equals, and I know that if negative 4 is a 0, x plus 4 is a factor. And now I can use synthetic division with this 0 of negative 4. So here's negative 4. My coefficients are 1, 3, negative 6, and negative 8. I'm going to drop the 1, multiply by negative 4. Sorry, yes, and get negative 4. Add, I get negative 1. Multiply, I get 4. Add, I get negative 2. Multiply, I get positive 8. Add, I get 0. Remember, this started off as a cube, so this is a square. Linear term constant. So my other factor is x squared minus x minus 2. Now remember, you have to factor it completely. So this is not my final answer because now I have to factor this quadratic right here. So I'm looking for 2 numbers that multiply to give me negative 2 and add to give me negative 1. I do know those 2 numbers. That's negative 2 times positive 1. Divide by the lead coefficient of 1. And since this is an x squared, this is an x and an x. So my final function is f of x equals x plus 4 times, this is x minus 2, and this is x plus 1. All right, one more. Given that 2 is a 0, so if 2 is a 0, I'm going to write f of x equals x minus 2 is a factor. I'm going to use synthetic division with the 0 of 2. And then I'm going to write my coefficients. 1 on the cube, 3 on the square, negative 4 on the linear, negative 12 is my constant. I'm going to drop this 1, multiply, that's 2, add, that's 5, multiply, that's 10, add, that's 6, multiply, that's 12, add, that's 0. So my other factor is x squared plus 5x plus 6. Once again, I want to factor this right here. So I say, okay, I'm looking for 2 numbers that multiply to give me 6 and add to give me 5. 3 times 2 is 6. 3 plus 2 is 5. My leading coefficient is a 1. This is an x squared, so this is an x and an x. So I have f of x equals x minus 2 times x plus 3 times x plus 2. And now you're completely factored. Go ahead and try those.